Here are the old Fairchild transistors, one of the first transistor companies in the Silicon Valley in the early days when the transistor was invented by Will Shockley, John Bardeen, and Will Bratton. And these guys are basically a tiny, tiny, tiny piece of crystal. They use germanium, or nowadays they use quartz. And it's treated with layers of phosphorus or boron, things like that. They actually have to put layers on them. And what we're going to do is we're going to see if it can affect my millivolts here. Although my millivolts are pretty high, so my background, let's see where I'm at right now. There, I've come down a little bit. I got 5 millivolts there, so we're going to see some increase here. Now it's pretty hard to connect with these guys because I have to connect it to the wire.
Okay, and these are just a crystal inside of a little plastic package.
There we go. Look, huge amplification. It's a multi-layered. You see that? 34 millivolts. You see those spikes?
Okay.
You getting that on the camera?
Yeah, it's jumping around a lot.
It's just hard to get a nerve contact here. There we go. There, 16 millivolts, 10, 13. That's higher than my baseline, 20.
Yeah, there's a lot of stuff going on with it.
Yeah, and get rid of it and come back, and it's staying in my body. You see? I'm still getting, and there you go, I'm going down again.
Ah, okay.
So what happens with it, and the crystal in here is chemically treated. What's really interesting about the first transistors is they couldn't get natural quartz to amplify electrical signals. But what's interesting about the body is any natural material, especially when it gets vibrationally treated with my process, will amplify. But they couldn't get natural quartz to work in a transistor. They had to put thin layers of phosphorus, very thin layers of different mineral-like materials to get the transistors to work. So this is a chemically treated piece of crystal inside of that little piece of plastic, and it has, basically your positive and negative and ground contact points on the little guy there. So this little guy amplified my body, and this little guy here, in the early days of radio, when they had tube amps, they used tubes to amplify radio signals. You couldn't transmit a radio signal more than maybe 50 miles without it really breaking up.
Yeah.
So radio wasn't really that good in the early days. Tesla, Lodge, and Stone were the true fathers of radio according to the U.S. Supreme Court ruling on June 21st, 1943. And Marconi, as a lab assistant, stole Tesla's patent and broadcast across the Atlantic. But that was early days radio. Now, your cell phone has literally millions of little transistors in it that are so small you can't even see them, with tiny pieces of crystal. And your Intel chip has over 2.7 billion nanoscale, which is billionth of a meter scale, transistors in it, which are tiny pieces of crystal. And what the crystals are doing in the transistors is amplifying signals. Like, let's say you need 100 or even 1,000 different shades of red. So you have to amplify all those signals. And then you have, millions of functions on your computer. And all those functions are amplified with little transistors. These size transistors went in the old transistor radios that I used to play with when I was a kid in the 1960s. So when you realize that the amplification this is what's really interesting, the amplification of the first transistors was on the microwatt scale, which is a millionth of a watt, and that the human body on the fingertips has more voltage than that, or the earlobes. You can measure voltage along the spine, the head, anywhere on the body. And so you think of the body as an electrical system, but then you think of the energy centers of the body, the chakras, as circuits in the electrical system.
Okay.
And the chakras correspond to glandular systems where we store minerals, right? The male prostate, we store zinc and copper and, all these minerals, right? And our bones are made of calcium and phosphorus and magnesium, the same things they put on transistors. right? So those are solid state crystal material, the bones. And then you have liquid, the bloodstream is carrying blood plasma, charged energy. And then you have the glands, you know, the adrenal glands here. This is where we get our big bursts of adrenaline and energy here.
So this really, what you're saying is, look, this solid state physics, which has been worked with for decades now in terms of information technology and computers and things like that. You're saying we can apply that to the human body, and here's how it applies.
And the way it applies is, and this is really interesting, like you think of your different chakras as needing different minerals and different types of crystal. Most gems are all silica based, which means quartz based gems, right? For example, a sapphire blue is an aluminum silicate, and the aluminum, it gives it the blue color, but it also, the aluminum and the quartz together makes it already like a transistor because it has semiconductive and conductive material in it.
Oh, okay.
So in ancient India, the different gems were very powerful and gave yogis advantages in attaining higher states of consciousness. And the reason is our different circuits, like here's our thymus gland here, and you have the pineal and pituitary gland in the brain, they store different types of minerals and different types of crystal to cause that energy center in the body to function. Well, with aura cameras, with the advent of aura cameras, we can now see the subtle light energy emanating off of the body. And what we did with our pendants is, you know, I'll open it up on the computer over here. We did aura camera tests to really make sure, okay, you have a change in voltage in the body. That's interesting, but what if it's only happening locally and it's not affecting the whole body? Well, it is. This is a guy at a trade show, buys a pendant, and he's holding a level 1. That's one of these, with no silver. And he's holding it in this hand. And you see how intense the blue energy is in the aura?
Oh, okay.
And how much brighter the gold is? And there's no green. The green goes away. And he gets this complete corona of gold. And which means his left and right hemisphere are much more balanced. And he's got the blue where he's holding the pendant. And this woman, this is before, and then you can see how...
Yeah, she had orange and green.
Yeah, she's very unbalanced on her left and right hemispheres. But nice colors, you know. The human aura produces a lot. And this is not the best aura camera in the world, but it's pretty amazing. With the pendant, instantly, her left and right brain are perfectly balanced.
Can I ask what kind of... Is that Kirlian photography?
Yeah, it's Kirlian photography.
Oh, okay, okay.
But then we decided to do way more advanced studies than that. We used the GDV aura camera invented by a Russian PhD in physics with multiple PhDs. And this camera, before, it measures how balanced the chakras are and how much energy is coming out of each one. And here we can see her third chakra, where her adrenal center is way out of balance because it's not in the center. And her crown chakra is out of balance, and her other chakras are fairly balanced. With the pendant, all of her chakras come into alignment in a perfect sine wave. And the amplitude, you see how much bigger the second circle is compared to here?
Oh,
that means there's more energy coming out of it. Her heart, the circle's bigger. Way more energy coming out of it. And so the same data converts to this graphic. We can see where this woman had breaks in her energy field in the lower body. See how there's no light coming out of... With the pendant, she's fully lit.
Oh, okay, okay.
Just like a light bulb, if you have more volts and more amps, you're going to have a brighter light bulb. Now this is very, very subtle light coming out of the body. And this subtle light, according to the discoverer of biophotons, Fritz Albert Popp. Fritz Albert Popp isn't the discoverer of biophotons, he's the discoverer that biophotons, mean living light, transmit signals faster than the speed of light. Faster than light. That means fast enough to talk to star systems if you know how to send your biophotons to a different star system. So we see a huge improvement, and the idea is that by wearing these things, we become more telepathic. Just like with the transistor, you could hear the baseball game. You could hear the president's speech for the first time, and you didn't have to listen through all the snow and the noise on the early radios.
You're just more receptive.
Yeah.
Yeah.
You become, so your psychic system becomes more receptive. Your thinking, faster interconnectivity between neurons and neuron transmitters in the brain and synapses in the brain. Everything is more coherent, which is why her chakras are more aligned. because they're talking to each other better, because the signal's better. You see, I mean, the other way to do this is to eat foods that have a lot more crystal content to them, and a lot more gold and things like silver, which we don't really have. I did studies on my own body where I ingested a lot more calcium and more minerals, and there's an improvement in my millivolts.
Okay.
But nothing on this scale.
Nothing like what the stones provide.
Nothing like what the stones provide. And in the Vedas, in ancient Indian medicine, gemstone powdering and putting gemstone powder in the body, because it will collect in the glandular systems, is the highest of all medicines. Higher than all plants and all herbs and all, tinctures and things like that. Because gemstone increases the conductivity and really gets the energy functioning better in the body. So that's kind of in a nutshell, what happens. When you have more conductivity in the body and you have better energy moving in your own biotransistor system, your chakras are going to function better. You have greater psychic and greater spiritual advantage. You have an advantage. In fact, even Paramahansa Yogananda, the very famous guru, the first guru to come and live in America, in California, his guru's guru told him to wear gems, and he said they have to touch the skin. The yogi said they have to touch the skin. And when you read this old book here, Out of the Crystal Maze, when they were trying to get the first transistors to work, the math said that the electrons were on the surface of the crystal, so it should become an amplifier, and all you had to do was run the wire by the semiconductor, and the electrons, like passengers getting onto a commuter train, would jump on the train, and you'd have amplification. And what's interesting about why they couldn't get natural quartz to work until they put it in water is because water is not just water. There's minerals in water, unless you have demineralized water. And with water, demineralized water transmits an electrical signal very weakly. Mineralized water, you can transmit electricity through that type of water very well.
Well, and it has that crystal structure in water too, right?
But salt water transmits an electrical signal incredibly well. And salt is crystal. Sodium is a crystal. It's a liquid crystal because it dissolves, but you basically have liquid and gas and solid state crystal in the study of in the hidden properties of materials. So why I think our pendants work with the body is because, one, the body has a moisture barrier, and in the sweat in the body, on the skin, you have minerals because we excrete salts and all kinds of things. So they work in contact with the body very well. If we take, for example, this is lapis, and lapis is a composite, and it has pyrite mixed in. That's the gold flecks of pyrite, and it has it has calcium, and you can look up the chemical signature of that. And just like the transistor, the way the transistor works that amplifies our radios and our computers is the conductor, in this case silver, has to be touching the crystal. It's the gap right there where all the magic happens on a transistor.
So the gap in between the silver band.
Yeah.
And
so I'm going to wet my fingers, and I'm going to put this along the gap and pinch, and put this along the gap and pinch, and I just got to get a nerve here. There, look at the numbers. 132 millivolts, 120, 118, 100 and... This is white howite, beautiful pendants. And howite is a calcium-based crystal. And calcium is an electrolyte, so it's pretty high energy stuff when it interacts. Let's see, 3.5 microamps. I just had it. Just hard to get the nerves to be active here. It was just there. Hang on. Really got to fiddle with it to make sure. There you go. 3.2. You see that?
Yeah.
Microamps. That's incredible. There's nothing on my fingers without the pendant.
Now you were saying again, this is the whole charges that are involved with this, right? Because this all goes back to the solid state physics for you.
It all goes back to solid state physics. So I was interested because the body is so weak electrically, we have, almost nothing in us. my baseline was really high because I wear this stuff a lot. It's very unusual. I personally tested over 1,000 people in person, and I've seen people that are 5 millivolts, a half a millivolt as their baseline before they touch this stuff, and I've seen people that are at best 30 millivolts. That's probably the best person I've ever seen. And when someone smokes a cigarette, you can get some pretty high readings because of the nicotine. So you have a chemical-based, induction in the nerves. The nerves run. You think of electrical wires that are running a light bulb or your computer. They run electrons, which are probably one of the smallest subatomic particles in quantum physics.
Yeah.
And they're the main carrier of the electric force. But in the nerves, we run positive and negative ions. And ions are generally a whole atom with either a negative or positive charge on it. But because most atoms, because they're bound, all the electrons are bound in the atom and the proton, they have no charge. Well, they say they have no charge because you can't detect the very, very, very weak either negative or positive. So our nerves are running positive, negative ions. But if there's electrons on the surface of this crystal, which there is, those electrons, if they transfer to the ions in my nervous system, they're going to create more charged particle action in my nerves, because that's what a charged particle is. It's an atom with either an extra positive or negative charge on it. You see? So they're basically called valence electrons. Basically, valence means they're unbound.
Yeah.
Yeah, and they will bond with something else because they're valence. That's in the world of semiconductors.